Hi, good morning, my dear students. I'm Daphne. Welcome to my STPM Chemistry discussions. I already discussed about the pH formula for the strong acid and strong base in my last video. Can we use this pH formula for the weak acid or weak bases too? Yes, we use back the same formula. Before I start the discussions, let's see what is the meaning of weak acid. Let's say this is an example of weak acid, HA. What will happen if I add in water? However, calculating the pH of weak acid is a bit more complicated. This is because weak acid doesn't completely dissociate in the water. Now, let's go to the first part, definitions of weak acid and weak bases. My dear students, let's do a quick recall about the topic that I discussed in my last video. The strong acid is dissociated completely in the water. Therefore, the concentrations of the strong acid is equal to the concentrations of hydrogen ion produced in the water. Therefore, we can substitute the concentrations of the strong acid given by the questions into the pH formula to determine the pH of the strong acid. Weak acid doesn't completely dissociate into the water. Therefore, the concentrations of the weak acid given by the questions is not equal to the concentrations of the hydrogen ion. We cannot substitute the concentrations of the weak acid given by the questions into the pH formula directly. We need to use this formula to determine the concentrations of the hydrogen ion. Then only we can calculate the pH of the weak acid. By referring to the ICE table, we can get this formula. By using ICE table, we can determine the equilibrium concentrations of reactant and products. Then we can calculate acid dissociations constant, degree of dissociations, and initial concentrations. I stands for initial concentrations. C stands for change in concentrations. This is the concentrations change required for the reactions to reach equilibrium. It is expressed with either an appropriate positive or negative sign. This is because this row represents an increase or decrease or no change in concentrations. E is for the concentrations when the reaction is at equilibrium. This is the summations of the initial and change row. Once this row is completed, its contents can be plugged into the equilibrium constant equation to solve for Ka. From the information given by the questions, we can use two methods to solve this example. First method, by using ICE table. First, we will write down the equations, then initial concentrations, next change in concentrations. We will say alpha is the amount of acid dissociating. Since acetic is dissociating, we use minus alpha to represent this change. Then we can write down the equations for Ka. Then, using these equations for Ka, substitute all the equilibrium concentrations and determine the concentrations of hydrogen ions. By using the pH formula, we can calculate the pH of acidic solution. An alternative method is using this formula.